All right, now that we've seen how you can take a 0-1 equation problem and turn it into a Hamiltonian cycle with edge pairs problem, we are soon going to see how to turn that Hamiltonian cycle with edge pairs problem into just a Hamiltonian cycle problem. But before we do that, I want to talk about a case where the 0-1 equation doesn't have a solution. And since we're saying that we should be able to reduce the 0-1 equations to the Hamiltonian cycle problem, what that should mean is that when I look at my Hamiltonian cycle problem, if I can't find a Hamiltonian cycle, that should mean that I also wasn't able to find a 0-1 equation in the first place. We've already shown that if you can find a Hamiltonian cycle, it's easy to translate that to a solution to your 0-1 equation. We need to show that the other thing also works. And we'll start with this example. Let's convince ourselves that the 0-1 equation doesn't have a solution. So remember that multiplying by this AB here is kind of like picking columns. And then if I have my variable equal to A, that's like picking the first column. If I have my variable if A equals 1, that's like I'm picking the first column. If B equals 1, that's like I'm picking the second column. So if I want to have a 1 in this first row, that means I'm going to need to pick my A column, because that's the only place that has a 1 in the first row. So I would need to have A equals 1. Similarly, the second row, the B column's the only one that has a 1, so I'm going to need to let B equals 1. But when I set those equal to each other, when I look at the third row, I'm using both columns, so when I add those together, I'll get 2, and that's not 1. So there's going to be no 0-1 solution to this equation. Okay, so there's no solution. Let's go ahead and look at the Hamiltonian cycle problem and see if that also has no solution. So let's start with coming up with some edges that represent my variables. So we'll have this representing A equals 0, A equals 1. This over here representing B equals 0 and B equals 1. And then we'll also have some edges on the other side, and these represent the different columns in the different rows in my matrix here. So I'll have a edge here representing that there's a 1 in the A column of the first row. We'll have a B edge representing that there's a 1 in the B column of the second row. And then we'll have both an A and a B edge down here, representing that I have both a 1 in the A and B column of the third row. We'll kind of connect these all together. And once we connect these all together, here's where we need to do the edge pairs. So what are my edge pairs? I can't set A equal to 0. Oh, let's number some things. So we have 1, 2, 3, 4, 5, 6, 7, 8. Now, I'm not allowed to take this A equals 0 edge and then use an A edge later on. So I have to pick one of those to use. So I'm going to have an edge pair that looks like 1, 8. I'll also have an edge pair that looks like 1, 5 for the same reason. And similarly, if I go ahead and use this B equals 0 edge, then I'm not allowed to use the B edges over here. So I'm going to have things that look like 3, 6, and 3, 7. And let's go ahead and look at why this Hamiltonian cycle doesn't work. So there's kind of I think the easiest way to see why this won't work is to actually go around the cycle kind of going the other way. So if I start here and I'm trying to do a Hamiltonian cycle, I'd need to use this edge 8, right? That's the only way to get across this gap here. So that means I'm using 8. That means I'm not using 1. So I'm not using 1 here, which means that I'm not using 1 here, which means that I also need to use 5. That's good to know for the future. So let's keep going. Oh, now I run across a 7 edge. Again, I don't really have any choices here. That's the only way to get across this gap. So I have to use 7. I'm not allowed to use 3. And since I'm not allowed to use 3, that means I also need to use 6. So I get down here, and now we run into a problem because I need to use edges 5 and 6 at the same time. And unfortunately, if I use edge 5 and then edge 6, I've made a little loop-de-loop without going to the rest of the graph. So turns out we can't actually do this. And that's kind of the problem we run into, is once I use edge 8, that forces me to also use edge 5. And once I use edge 7, that also forces me to use edge 6. And then that leads to our problem. So there is no solution. There's no Hamiltonian cycle. Well, no Hamiltonian cycle using our edge pairs. So again, we need to kind of justify, if I can't find a Hamiltonian cycle with edge pairs here, that means I also can't find a solution to my problem there. And I'm going to write that out because it's actually much easier to justify something else. So if I can't find a Ham cycle, I can't find a solution to the 0, 1 equation. Okay, that's what we want to justify, and that's actually kind of hard to rationalize. It's hard to say, well, I wasn't able to find something here, so I also wasn't able to find something here. It's actually much easier to look at the contrapositive here. Contrapositive says, if I can find a solution to the ZOE equation, then I can also find a solution to the Hamiltonian cycle. And this video is not the best place to demonstrate that, because for that you want to actually look at one that works, and I'm making this much later on, so we're going to see if this problem still has what I want. Oh, no, that's the wrong thing. How about this? This is better. And that's exactly what we saw earlier. If I knew what my solution was here, a equals 1, b equals 0, then that tells me exactly how to find my Hamiltonian cycle. It tells me that I'm going to use the edge. I'll go ahead and draw it. It tells me I need to use the edge a equals 0. It tells me I need to use the edge b equals... Nope, let's try that again. I need to use the edge a equals 1. I need to use the edge b equals 0. And then I use all the a edges. And ta-da! That is a Hamiltonian cycle, and it meets all of my edge pair stuff. I used exactly 1 of 1 and 8. I used exactly 1 of 1 and 6. I used exactly 1 of 1 and 5. And I use exactly 1 of 3 and 7. So we do, in fact, get this property that if there's a solution to my ZOE, then I can also find a solution to my Hamiltonian cycle. And ignore this, because this is what you'll see in the next video. But there you go. So I just wanted to show you an example where there isn't a solution to the ZOE, and therefore there's not a solution to the Hamiltonian cycle, and vice versa. There's not a solution to the Hamiltonian cycle, and therefore there's also not a solution to the ZOE problem. So there you go.